I know it is counterintuitive, but realistically, most technology gets worse over time. Your car, your phone, they start degrading the moment you use them. However, there is a new kind of technology being built that does quite the opposite. It improves itself, and it is learning to do it faster and faster. It is called Recursive Self-Improvement, or RSI, and it might be the most important concept in technology today. RSI is the key idea of an AI that can rewrite its own code, design better versions of itself, and accelerate its own development, potentially without human help. I truly believe that RSI is coming next year at the scale, and that it will change everything once again. So, by the end of this video, you will understand what recursive self-improvement is, why it is being compared to nuclear fusion, and what happens when it reaches the point of ignition. So, let's dive in. The core idea of modern RSI is simple: learning by doing. You know, for decades, the concept of self-improving machines have been purely theoretical. Early attempts required the AI to formally prove that a change would be beneficial, which is an almost impossible task for complex systems. Now, the breakthrough was to relax that need for proof into a simple experiment. Just try a tiny change, just a little bit, and see what happens. And AI can now rewrite its own codebase, test the new version, and if the change works better, it merges the new code into its main branch. It is like mutation, selection, and inheritance, but applied by a machine to its own source code, at digital speed, of course. And just to be clear, this idea of a self-improving system is not entirely new. A car factory that studied data from its own assembly line to recognize its layout for better efficiency, you know, the process that the Toyota called the Kaizen, is actually a recursive self-improving system. The statistician I.Y. Good, who worked with Alan Turing, he predicted an intelligence explosion from such a machine back in 1966, calling it the last invention that man need ever make. But it was the method, relaxing the need for perfect proof, what finally unlocked the potential of this quite old idea. This brings us to a critical idea: break-even. In fusion research, break-even is the moment a reactor produces more energy than it consumes. Recursive self-improvement has its own version of this. Call it the ratio of capability the AI loop produces to the human effort the loop consumes. Right now, we are below break-even. Humans still supply the goals, the direction, and the judgment. The machine is a powerful partner, but it is still a hybrid system. However, I personally believe this situation is about to change very, very soon. You take Anthropic, for example. They report that over 80% of the code for their production systems is now written by cloud code. Their internal experiments show that on a specific task, cloud code can find a 50-fold speed up, where a skilled human engineer finds a 4-fold instead. It is mind-blowing, I know, and it is already happening in the open. Andrew Karpathy, we all know Andrew, of course, He published a project called Auto Research on GitHub. It is a few hundred lines of code that lets an AI agent experiment on another AI model, proposing changes, testing them, and keeping what works. It ran 198 experiments overnight with zero human intervention. And the core loop of AI research, proposing, testing, and keeping of good ideas, now it fits in a few files and runs while its owner is sleeping. So the system is not yet self-sufficient, as we know, but the amount of human effort required is shrinking very, very fast. If Breakeven is getting more out than you put in, Ignition is the next step. In fusion, ignition is the moment when the reaction can sustain itself without external energy. For RSI, the analogy is precise and observable. Ignition is the first moment an AI model produces a successor model that is more capable than itself, with no human left in the loop. At that point, the process compounds. Each generation builds the next. Better versions build even better versions. And this is like putting a turbocharger on the time axis of evolution. Because as we know, biological evolution took 4 billion years. It needed a lot of random mutations and the time it took from one generation to another. However, AI development compressed that whole process into weeks. RSI compresses the compressor. Once the loop ignites, the main limit on progress is no longer intelligence. Intelligence is what the loop manufactures. So you may wonder, what is the limiting factor right now? Well, it is purely physical. Compute and energy, basically. High quality chips and the electricity to run them. But to solve this problem, the answer is the AI itself. The loop doesn't just stop at making better AI models. It can be pointed at the very things that constrain it. For example, an AI could learn to design more efficient computer chips for itself, or discover novel materials for better energy generation, feeding those discoveries back into its own hardware. Some economists compare AI to past technologies like railroad or electricity. They say this thing took decades to show up in productivity statistics. So we should be patient. But that analogy contains its own refutation. The railroad built in 1870s was the same railroad in 1890s. The technology was static. It waited for society to catch up. AI is the first technology on that list that improved during its own diffusion. And with RSI, it improved the rate at which it improved. Like, for example, imagine a race car that not only drives, but continuously redesigns its own engine while it is racing, getting faster with every single leap. And that's a big difference. This creates a gap we have never seen before. A laboratory running at the speed of compute, while the world around it moves at the speed of trust, regulation, and human habits. Every previous technology eventually stood still to let society close that gap. But this one doesn't have to. And that brings us back to the main point. We are not at the end of history, we are at the beginning of a new history. Everything up to now, empires, revolutions, all of it has been written at the fixed clock speed, set by human lifetimes and institutions. RSI is the first moment the clock itself becomes an output of the process it times. The acceleration ahead has no precedent. So, what is the takeaway for you? Well, recursive self-improvement is a process that could fundamentally change the pace of invention itself. We are moving from a hybrid system where humans and AI work together towards a potential ignition point where the system becomes self-sustaining. The key takeaway from me for you to think about is that AI is not just a tool like hammer. It is a process like evolution, and that process is starting to run itself. And the next time you see a demo of an AI doing something amazing, you just don't ask, what can it do? Instead, you can try to ask, to what extent can it teach itself to do this better? Because that is the most important question right now. And if you like this video and you want to keep tracking our progress towards ignition in the field of AI, consider subscribing to the channel for more videos like this one. Thank you very much for watching, and see you in the next one. Bye.